Now I'm recording. Okay, so now we're recording, so we're going to get started. And so today we're talking about multiplexers and decoders. And so the first thing we want to talk about is what is a multiplexer. So does anyone want to volunteer to give any insight onto what a multiplexer does?
A multiplexer is, from what I remember, it's a switch where a 0 gives you input 1 and a 1 gives you input 2. Probably.
Along those lines, a 0 gives you input 0 and a 1 gives you input 1. But yeah, it's a switch. So what you just described was a 2-to-1 multiplexer. And there's also a 4-to-1 or an 8-to-1, and you can build them to be any size. So what a multiplexer is it's a kind of like a switch to choose between different inputs. And in a lot of ways, it acts somewhat like an if, else, or case statements. So depending on the value of one input, you will choose between other inputs. And so that makes it somewhat like an if or a case, except an if or a case you can have whole actions in there, not just values, but this just chooses values. So how do you represent a multiplexer in a circuit? So a multiplexer looks like a trapezoid, and you'll have one output because you have multiple inputs but one output. And then you have some inputs that are tell you which to choose. So like if you had an if statement, you would have like if x equals 1. So that's one thing. And then you have your then, which is what you do. And so I'm going to draw a 4-to-1. So it would have 4 different inputs. And to choose between those, you would have you'd have a 2-bit variable, because with 2 bits you can get the values 0, 1, 2, and 3. And so you would have 2 select variables or control variables. Probably should draw that the other way. Make this one a 1 and this one a 0. And sometimes you see those select or control variables drawn at the top like that, or you'll see them, you could see them drawn at the bottom as well. So that's a 4-to-1 multiplexer. A 2-to-1 multiplexer looks like this. You just have one input, or one control input, and then you have the 2 values right there. And then we'll practice with what that means. So given that, how many inputs does an 8-to-1 multiplexer have? So how many inputs would we have? Well, we clearly have these 8. But how are we going to choose between those 8? So if I have an 8-to-1 so if I have an 0, 1, 2, 3, 4, 5, 6, 7, I'm going to need S2, S1, and S0 to get all the values between 0 and 7. Because 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and so forth down to 1, 1, 1. And so these 3 variables would tell me which of these to choose from.
I've never had that explained so well before.
Huh.
Like that was crazy.
Yay, I'm crazy. All right. And we're going to practice actually using these. I think maybe I'll do that before we look at the pin layout and truth table. Let's look at seeing how these work. So this would be, oh, we'll do this problem, which is number 3, sketch F for the given circuit. And this one is a 4-to-1 multiplexer. So that's what we're going to do. So I'm going to copy it here. Let's see if I can paste today. Who was anyone at my session last week when, like, my computer just chose not to paste? Yeah, just the paste was just not working. It was crazy. All right. So here we're going to plot the output F based on this multiplexer right here. And I have all of these inputs up here. So F, here would be 1 and here would be 0. So when we start, let's look at the control inputs. So S0, I'm just on the fly, well no, I better leave them the way they are. I should have done S1 on top and S0 on bottom. Would have been better, but I didn't. So 0, 1, and 0, 1. So I'm going to write them over here, S1, S0. So when I start, S1 is 0 and S0 is 0. So that corresponds to input 0. And if I look at my multiplexer, input 0 is A. And so until my select inputs change, my output is going to be whatever A is. And A during this time is 0. Okay, so when I get to this dotted line that I just drew, my control inputs change, and S0 becomes 1, and S1 is still 0. So that's input 1, which is B. And so if I look at B, so I'm going to look at B up until these change. And B is 1, and then it becomes 0. And then my control inputs change again. And now S0 becomes 0, and S1 becomes 1, and that means input 2, and input 2 is C. And so during this time period, I'll be like C, which starts at 0 and then becomes 1. And then S0 becomes 1, and S1 remains 1. So that's input 3, which is D, and D during this interval is 1. Does that make sense? Yes? Yes. All right. Practice one more before we look at, let's see, what time is it? No, I'm going to go on. All right. Let's look at the data sheet. So this is, I got the decoder. Let me get this is 74LS151, the 8-input multiplexer. So we would like to get the truth table and the pin layout for this so that you'll know how to use it. So that's what we're going to do. And y'all know where I got this from? Yeah, from the lab resources, where it has the data sheets available in the lab. Or now that you have it, you don't need it because you have it now. So for all of these chips, you always have to be on the lookout to see if they are positive high or positive low, like are active high or active low, because sometimes we're used to things always being active high, but sometimes they are active low. So we'll check this one out and see. And this is what you'll be using in the lab. You don't have to copy this, no. You would want to copy the important parts, and let's see what the important parts are. So first of all, you will need to know where the different pin connections are. So as usual, 8 is ground and VCC is 16. Actually, haven't we usually had 1 through 7? Aren't the and ors 14 pins? Yeah, so that's different. Does anyone know if OneNote has a rotate?
Try the middle one.
The middle.
The middle block. That's outlined and like a little bit up.
That's not there.
No.
No. Okay. Well, we'll just. To me, that looks sideways. I don't know. I'm used to them being the other way. It doesn't matter. There's no difference.
Might be able to or whatever.
Oh,
Rotate.
Yeah.
Thank you.
Hey.
I like it like that. Okay. So as usual, ground is this one, and VCC is this one. Okay. So let's take a look at what the others are. So notice this one is. It says enable. If you look, enable has to be low, and that is usually you would expect enable would have to be high, but enable has to be low. So enable is pin 7, and that has to be low. So what does that mean you'll need to do to pin 7? Pin 7 needs to also be ground. So it's not going to work if you don't do that. So pin 7 needs to be ground. And then let's look at, let's see.
So 7 and 8 are grounded?
7 and 8 are grounded. And notice that if I had looked at the this description right here, the enable input is active low. That's what I was just talking about. Active low means that you turn it on by having it at 0 instead of at 1. And now let's look at the output. So notice it has S2, S1, S0. Those are pins 11, or 9, 10, and 11 are 0, 1, and 2. And that is going to control which input you're taking. So those are, that's just like our S0, 1, and 2 when we just draw it out. And so when it's low, 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 which would correspond with our 0, 0, 0, then that means it's selecting I0, which is pin number 4. And the way I can tell that is, notice it says I0 is the output, which is, we have 2 outputs, both conveniently labeled Z. One is actually Z and one is Z bar. So if you look at these outputs over here, let's determine which is which. So when I0 is low, I don't know which Z that is. Does anyone see what my issue is, and can anyone explain what my issue is? There it is. Okay, so pin 5 is Z and pin 6 is Z bar. Note B. Output load. Okay, that first one is a Z bar. Okay.
Why do you guys have 151 instead of 138?
I'm sorry?
It's 151.
151 instead of 138. You're using both?
Oh, okay.
Yep. Yeah, 138 is the decoder and 151 is the multiplexer.
Okay.
Yep.
Sorry,
Okay, so this one is Z bar, and this one is Z, and I already forgot which one is 5 and which one is 6. Does anyone remember which one was 5 and which one was 6?
Z bar is 6.
Z bar is 6. So you're probably not going to be using that one. So pin 5 is your output. This would correspond to what I had as F. And if you look, this pin 5, which is this last column, if my input, my selects are low, 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 0, 0, 0, then if my input into I0 is low, then my output is low. If my input into I0 is high, then my output is high. So what that means is when S0, S1, S2 is 0, 0, 0, then F equals whatever is coming into pin 4. And I1 is pin 3, so that would be if my select was 0, 0, 1, then my output F would be whatever is coming into this one right here, I1. So we have I0, I1, I2, I3, I4, I5, I6, I7. Those pins are equivalent to our 0, 1, 2, 3, 4, 5, 6, 7. So this 0 is pin 4, 1 is pin 3, 2 is pin 2, 3 is pin 1, 4 is pin 5, 5 is pin 4. Could they make this any more confusing? 6 is pin 3. Wait, I messed up somewhere in there. Don't count on any of that. Don't just look at the whatever it has on the diagram. I messed that up. So I will get it right. Let's see. So do this in a different color. 0 is pin 4. 1 is pin 3. 2 is pin 2. 3 is pin 1. 4 is pin 5. 5 is pin 4. 6, oh, that's pin 14. 4 is pin 15. 5 is pin 14. 6 is pin 13. And 7 is pin 12. And your output is pin 5.
Is 4 15 or 16?
4 is 15. That's supposed to be a 15. And 16 is VCC.
Oh, gosh. They just like sign randomly.
It seems that way, but I'm sure that has to do with this placement of the circuits inside. Okay, so I'm going to stop here and save this video, and then I'm going to start and I'm going to talk about how you implement a function using a multiplexer, and then we're going to start all over with a decoder. So I think I'll do them in that order rather than the order that I have on the handout.